First of all, welcome to AirVenture 2022, the greatest air show on earth. That's my words, but I think it holds true. And welcome to Home Built and Review. So this is a program we have twice a day at 10 o'clock and 1 o'clock. So we got 2 more versions after today. We got 2 more tomorrow, and then that'll complete our AirVenture series, which we've done 5, 6, 12 different things. So today, we've gone a little bit beyond just an airplane and a person. We've got an airplane engine company, but we've got a nice airplane that's running the same engine as a representative. So my name is Joe Waltz. I'm on the EA Humboldt Aircraft Council, and also from Conroe, Texas, Chapter 302. But there we go. My critical. This will be your mic, and this one audio on the mic. We're going to have to pass it back and forth there. So, Jan and Alyssa Eggenfeller from, well, I'm going to let you tell us the name of your company and tell us where you're located, and then we'll continue from there.
Yeah, Jan and Alyssa Eggenfeller, like Joe was saying, and we're based out of Florida, a little airport called Viking Aircraft Engines. It's Edgewater, Florida, just a little bit south of Daytona Beach. And we settled there because it's kind of mid-Florida, it's beautiful, and we can leave the hangar door either closed or open and have a nice place to build our engines.
Okay, so we're going to go into in just a minute to find out about all those different engine variants. David Tillema on the end on this beautiful, go ahead and introduce yourself, David. Tell them what kind of airplane you're flying, and go ahead and tell us the model number of Viking, and then Jan can expand on their product line.
All right, my name's David Tillema. I'm from Friendswood, Texas, south of Houston. I'm flying the Zenith CH-750 Cruiser, affectionately known as Jumbo. She has the Viking 130 with the Duke variable in-flight propeller system, which is just quite amazing.
Okay, so that's kind of a neat intro. Let's get back to Jan and Alyssa. You guys pass it back and forth. I know, Alyssa, you're kind of the voice of the company, maybe. Jan knows a few things about it too. So whoever wants to answer the question, it really doesn't matter. And we're going to get to some Q&A a little bit later on. Hope you don't get too hot out there in the sun, but hang around for the Q&A. We're gonna talk up here for probably up to an hour. Depends on how it goes. So, Jan, let's expand a little bit more. You told us where the company is. Get into the product line that you have.
Well, our business is to convert car engines so they can fly in home-built airplanes. We tend to use mostly Honda engines. In fact, we use all Honda engines except one. We have a little Mitsubishi engine that we use, that we convert, and we do all the horsepowers. We do 90 horsepower, we do 130 horsepower, 150, and then we got our larger one, our turbocharged engine at 195. So those are the things we do as far as converting car engines to airplanes. And then, of course, most people that come to us and want to use our engine for their home-built airplane would ask us, well, how do I mount this engine? What do I do with it?
Well, that's exactly what I was going to ask. Yeah.
Well, yeah, so there's a lot more to it that we also specialize in. So we do the entire firewall forward package, and Alyssa does package several of those up every day or every week that go out to customers. So I'll have her talk a little bit to you about what is included and the importance of the customer service and making sure that builders aren't like just left there with having to run to Home Depot or order things from McMaster-Carr, or that the completeness of what we do to make it easy for the customer, I think is why we've become very successful at what we do.
Right. So, well, one more thing, Jan. Alyssa can answer it for us. 4 engine models, and basically the model number is the horsepower that you're getting out of it. Is that correct?
Yeah, that's correct.
Okay. Now those 2 top-end ones, I'll call them top-end. You got 185 horse and a 1.
We have 195 horsepower is our largest engine.
And is it the same as the next one down, but just with a turbocharger?
No, in fact, it's not. They're actually all different models for different cars. So where our 90 horsepower is a 1.2 liter Mitsubishi Mirage engine, and then we move up to the 130, that is a Honda 1.5 liter. It's the little fit car. And then from there, we do the 150 horsepower that comes out of the 1.8 liter HRV, and the turbocharger that is on our big 195 turbo is from the car itself. So we're not adding on a turbocharger onto the engine. It's already built for it.
That's the way it comes off the assembly line for the cars themselves. Which models do we have here?
The one to your right there is our 195 turbo, and on the opposite side, you'll actually see the turbocharger.
Okay.
And in front of us here is the 130 horsepower engine.
Excellent. So, and they're in the, well, pretty much like what you would, is this how it's going to show up when I order it?
Yeah, exactly. So our engine and our pricing that we give for our engine is basically ready to run. So we run them before they leave, and they have the computer on it, the aviation grade wiring harness, all of that is as it is. And then depending on what airplane you have, we specialize in making that firewall forward as complete as possible for you, and that all goes in the box. And
Does that include mounts?
Oh yeah, so for over 40 different aircraft in the experimental realm, we have the engine mount, the cowling, the pins that go in the cowling, your fuel system, your radiator, your cooling system, your propeller, your spinner, different options of propeller from variable pitch to constant speed to ground adjustable. So you are going to have every little piece that you need and above and beyond what's typically offered. Even the batteries and contactors and coolant and the tools that do it, and even in something such as the Zenith, we offer things above and beyond engines for the aircraft itself.
So they're all water-cooled engines?
They are all liquid cooled. Yeah,
Liquid, okay.
Yeah, we use a NPG wireless coolant in our setup, which means obviously under the cowling you're having a lot lower temperatures compared to your standard air-cooled engine.
Yeah, so maybe Jan is the best to ask you, why do I want to do an auto engine? It seems to me, from the outside, it's probably because prices are going to be a whole lot less.
Well, it used to be that way. We used to be like the alternative engine place. If you didn't have any money, or you were scrounging and you were like wanted to get your own core and put some pieces on and maybe bolt a drive unit on there and all that. But that has all changed. We're no longer an alternative engine of any. We're actually become a primary engine company for home-built experimental aircraft. Clear example, of course, is Zenith Aircraft, which we supply 75-80% of the engines that are being used by the builders that complete those airplanes. So I think the last 10 years and accelerating every year, we have shown that these engines work, that they're modern, that they are more compatible with what you're used to when you buy a car, which is that they start instantly, they run smooth, you get the benefit of mass-produced engines, so you get a huge amount of technology and in a package that doesn't cost anything. And of course, that's only because they come from something like a Honda Accord or something. Honda has made more cars, or they're making more engines right now today when we sit here than Lycoming and Continental and UL and Rotax and all those combined have made in their entire career making aircraft engines.
So let's pass it down to Dave for a second. Jan just said that, what did you say, 85% of the Zenith people are choosing your engine?
Somewhere around there, yeah.
Okay, so there's other engines on Zeniths. Why did you decide to put this engine on your aircraft?
Well, my mission was to have a plane that I could fly, not the one that I had to constantly work on. Super reliability was paramount because I wanted to travel the lower 48 states. So this was not the first engine in jumbo. The first engine was very unreliable, nothing but a maintenance nightmare. I removed that engine 95 hours, and then during that time I already knew it was problematic, so I had stayed in touch with the Viking, and when it bit the ghost, I was like, how quick can you get me back in the air? Within 2 weeks, I was back in the air. Oh, yeah. So I've been back in the air pretty much every day since. So you had to change everything out, right? Yeah, we did a retrofit. They shipped the engine and everything over. I pulled my previous engine off. They showed up. They do a they'll travel to install your engine for you if you want, and I wanted to be back in the air as quick as possible without any issues. It took them 3 days. We both worked on it. Took 3 days to get back in the air, and yeah, it's been a dream since.
I understand why you got him at your booth now. I mean, that's a great sales point because most people decide on the engine when they're building it, and they stick with it. That's because you spend so much money on it.
Well, let me
So
say
when
this,
you did a swap out, that's incredible getting it going that fast.
Yeah, and it's this September will be 3 years that Jumbo's been in the air. This engine has 700 hours on it. The plane has 800 hours in less than 3 years.
Wow, that's a lot of fun. We're going to get to another neat story about Dave. If you notice on the side of his airplane, he's got a little map of the United States. So you didn't exactly come with a straight line to get here, did you?
No, I've got problems with navigation apparently.
Yeah, so okay. Which, wrong way, Dave.
Yeah.
How many states did you have to stop in before you found Oshkosh?
Well, I hit all 48, and I flew over Wisconsin prior to finishing, but I left Wisconsin for last. So
There you go.
we did all 48, and we did it in record time. The record was 16 days, 12 hours something with 2 pilots. We did it in 10 days, 1 hour and 9 minutes, solo.
Wow. Well, here's that's plays tribute to the engine, reliability of the engine.
Absolutely.
Because how many hours of flying was that?
That was 60 point something hours in the air, and there was another 20. It was like 20 hours actually, so it was 80 hours total. But when you're touching and seriously, there was a lot of ground time. So
That brings to mind, or a question in my mind then is, how often do you do an oil change?
well,
I don't change your oil in my car very often.
yeah, the gearbox is every 25 hours, but it's only 8 ounces, so that was easy. No issues there.
Okay, so the gearbox is a separate oil system from the engine. We'll get into those details in a little bit.
And the engine itself is recommended around 55 hours, but I am kind of the unofficial test destroying pilot. So my goal is to see if I can make this thing break. So I push it, and I've gone as high as 88 hours with oil samples, and it still does good.
Well, one of the big problems with a typical aviation engine is you build up all that sludge in the oil because you're burning fuel that has lead in it. So what kind of gas did you burn around the 48 states?
This entire challenge was done only on auto fuel. 91, 93 octane, no lead at all.
But it is a whole lot less than aviation gas.
It is, and with that, I was wanting to do it from the very get-go, and then last year it would have cost half as much as this year.
Sure.
But it's still cheaper to do auto fuel, low gas versus 100 low lead, so it's just remarkable.
So from the operator standpoint, I'm dealing with that. I've got spark plugs. How often do we change those? I'm trying to think of what I have to do on my aircraft engine and how much maybe easier it is with this engine.
Well, I've got 700 hours on my engine, same as that one, and I tinker. And every year you do your conditional inspection, so I'll pull the plugs out. And throughout my testing with leaded fuels and stuff, I wanted to get my compression back. So I changed my plugs out. They didn't need to, but I did. And I changed the serpentine belt out. Other than that, it's oil.
Okay, so you do burn leaded gas once in a while. It can go either way?
Only as an absolute necessity, but it will burn it. But then I add a additive called Declan that is a lead scavenger that offsets the lead buildup.
Okay, so I was going to ask Jan, how does the lead affect the valve system and any kind of potential buildup?
Well, you want to stay away from leaded fuel if you can.
Okay.
Yeah, it's just like any like Rotex says the same thing. Yoil says the same thing. Jabber says the same thing. I mean, it's not good stuff for any engine. But you put the additive in when you can't get aviation fuel. But one thing I was just listening to. So how much oil? Because you kind of asked it, but he didn't answer it. How much oil did you use on this 48-hour thing? Well, and one more thing, do you think that you could have gone 700 hours without ever changing the spark plugs if you had used car gas the whole time?
Sounds like a leading question, so let's hear it from the operator standpoint.
Okay, well, I'll answer the spark plug thing first. If I didn't use under low lead, I would never have had to touch any part of the engine other than oil changes. The oil that I use,
That's going to help the plugs, the life of the plugs is the
Yes.
no lead, yeah.
correct. So, and it also helps your compression not using lead. So we ended up going 80 point out whatever hours on this one, but I topped it off at 4 quarts when I left Friendswood. I didn't add any oil the entire trip. I didn't have any oil slicks underneath my plane like some engines do. And when I had to refuel it, or when I switched the oil out here, I was a little over a quart low. So, but which was normal for a long flight. I mean,
Yeah,
I would, that's remarkable.
That's not bad. Yeah, that's great from an operator standpoint. So you need reliability. You hit all these states, you're out by yourself. Sounds like that's what you got out of it. Okay, Jan, Alyssa, I'm going to ask you, so you buy the engine from, I'm not sure where your suppliers are, but it's an automotive engine. You have to add a few things to it, right?
Yeah,
And do you build them or outsource? How's that process work?
we build them all in-house. The engines themselves, we don't mess with the internals of the Honda engine whatsoever. We've never found a need to, and we've never had internal engine issues at all. So we're not going to mess what Honda kind of spent their time doing.
Sure.
And then we add on, obviously, our gearbox and everything that involves.
Is that made in-house, the gearbox?
Yes, it is. The
Okay.
machining itself is housed out. It's our design, but they're
Okay.
assembled in-house, yes.
So it's just a bolt-on, and I can understand now why it's got its own independent oil system, separate from the engine. Because like you said, you don't want to mess with the engine. It's a proven design. Alternator is that similar to what comes on the car?
That's actually, we don't need the big alternator that comes on the car. So we have a 40 amp Nip and Denso alternator on there. And
Okay.
on the back, we obviously have mounting hardware. And there's little nuances throughout. Like we do our own tough cell aviation grade wiring harness and computer. And so there's a few things, but the idea is that you can get everything affordably and you don't have problem with parts. So that's part of not changing the internals of the Honda engine. If you need something, no matter where you are, you can get it.
It's a worldwide distribution system. Yeah.
Yep. So like we're a lot of people are kind of struggling right now with lead times and parts and stuff like that. We're able to ship within 2 weeks and have everything out the door as a full kit for whatever you need.
So I call you today, I said I need an engine, and Dave got some special dispensation, it sounds like, but you can get me an engine in 2 weeks.
Yeah, that's not abnormal. In fact, many times we ship next day depending on what's going on. And
I don't think Lycoming or Continental could come anywhere close to that. I think Lycoming's almost a year out or something. It's pretty crazy right now.
yeah, and then you wind up with a more affordable package overall. Like typically our entire kit, engine, all the way from the mount to the propeller that we offer is pricing wise is usually less than the engine alone for any other options out there. So we really take advantage of mass production in that way to be able to supply a very affordable product for people that can outperform.
Super. So we've seen it on a lot of Zeniths. How many other different aircraft types do you have them installed on?
We have about 1,200 engines worldwide, and we have a couple international distributors as well. So we have over 40 different firewall forward kits that we have. So pretty much everything on the experimental realm, from Zenith to Rands to Kitfox to Velocity to a little bit of everything out here. We've done more than once from many different models. So
Anything, is anybody running one on an RV?
oh yeah, we have RV12s, RV9, RV7. We just started doing that as well, but we really are accustomed to just making a mount. All it takes to do something new is send us your firewall, as long as it fits what the plane needs as far as horsepower and weight.
Yeah.
Send us your firewall dimensions and an extra 2 weeks, and then you'll have a mount and everything you need for that as well.
Speaking of mounts, I'm looking at it, so it's not a bed mount like some cars. It's more traditional airplane coming out on the backside.
Yeah, correct.
And it makes it easier to make the whole mount for the airplane, I guess.
Oh, for sure.
Yeah, cool. So, am I correct in saying just the gearbox is the main component that you guys add? You stay with the computer that comes with it?
No, we don't. We do our own computer. We obviously don't need everything that a car engine needs, so
Okay.
we change the harness we have, and he can elaborate more on that. That's one of the changes.
Okay.
But a gearbox and the R&D that goes into that and everything that involves making that reliable and everything that it needs to be, then that's one of the bigger components, which has a lot of benefits as well outside of being airborne.
So we were talking about the gas versus low gas. Obviously, they're different octane ratings. So, did you retain the anti-knock protection that these engines had built into them? Or the knock protection? I'm not sure what they call it.
Yeah, we do. Now we have port injected engines and direct injected engines. Now, for the direct injected engines, the immunity to knock is incredible. You can inject fuel early in the piston stroke, and it cools the inside of the engine, and the engine's almost knock proof because of it. You can run a lot more ignition timing, a lot more boost if it's a turbocharged engine, and the engine can produce more power than what you would traditionally think that a 1.5 liter engine could. All engines have knock protection. They have a knock sensor. Like you were asking, like what do we really do if it's just like a stock engine from Honda? And as a designer, I'd be like, oh yeah, we're gonna change everything, and it's all my creation and all that. But that's not true. We focus our efforts on what's important. So design the gearbox, design the engine mounts, made the intake manifold work on the engines, do a little shaving down on the throttle body to make that work, a little lighter alternator. We do our own exhaust system. We figure out the cooling system. We figure out, how the engine's going to be mounted in all these different airplanes and what kind of offsets to the right or up or down or whatever. And we flight test every engine in every airplane, and we document everything. So, and then we do all the dyno testing, and then after all the dyno testing is done, then we take it to the air and we continue to fine tune air fuel mixture and ignition timing and all that. And we do all that with low grade gasoline, so that when you go from 87 octane to 89, you have that little buffer. So you want to use 89 octane or above. So we do all that, and yeah, there's a two-edged sword by telling people that, yeah, it's just a car engine with a gearbox, because essentially that's what it is. But if it was really easy to do what we do, you'd see a lot more car engines flying. So it's all in the details, like for instance, we would get a customer, can I get into your computer? Can I get my laptop and tweak it a little bit? It's like, no, we cannot let you into that, because that's where all the magic is. That's what makes it start, that's what makes it run, that's what makes it efficient, that's what makes it have the peak power that is allowable within a reason without destroying the engine. So yes, there's a lot to it, but at the same time, when you get the engine, you can buy every part in that engine from Honda.
What's the reduction ratio on this gearbox?
2.33 to 1.
So now the engine is rated at what kind of RPM? 7,000?
Well, it's in the car is rated at like 6,700,
okay,
which we never see. We don't even get close. Yeah.
Yeah. So okay, then you're going to reduce it down to, well, what's your prop RPM at cruise?
Well, we don't start from 6,700. That's in the car.
Yeah.
So we pretty much figure like, same as road tax, like 5,700 RPM is our maximum. So that's 1,000 RPM lower than the red line in the car, which already has a little bit of cushion to it. And then then you reduce it from there. So our optimum propeller RPM would be around 2,200 for efficient cruising.
That's a whole lot quieter than 2,700. So I'm getting a noise reduction also.
Yes, exactly.
Now propellers. So you got your own propellers that you hang on them?
We work with Duke out of France.
Okay.
And we've learned that working with a propeller manufacturer has given us a lot of benefits, because they have already a very nice propeller, and then if we want to enhance our engine using that particular propeller, then we work with them, and we did. We had them develop a variable propeller system for their hub, and then we developed the actual mechanism that goes on our engine. So it's a matter of having then a hole in our gearbox throughout, where we can put a shaft through the gearbox, and it's a very simple actuator that then pushes against the mechanism in the propeller hub and allows you to then turn the blades if you want either a variable propeller or a constant speed propeller. So rather than having brushes and a motor in the spinner, which kind of complicates things and puts weight out of the spinner, the propeller is completely simple, and then the actuating mechanism is on the side of the engine.
So you do have a constant speed prop available on which engine models? The biggest one here?
On all of them.
On all of them?
Yeah.
So is that capable of acrobatics? If you can handle those kind of loads?
Well, it can. The limitation is more that our engine is not set up for that. Our engine is set up for, loops and rolls and barrel rolls and things like that, but it's not really designed to be upside down because
positive G stuff.
Yeah. But the propeller itself, sure, because it's so lightweight, then you multiply that into like forces exerted on the propeller disc and everything. You can do aerobatics with it.
Okay,
yeah.
That's good. Yeah, so because I know some electric props, you said it wasn't electric, it's mechanical. Some electric props, you really don't want to do those kind of loads that aerobatics puts on the prop. Is it possible to put a different prop on it other than what y'all provide?
Yeah, you can put any kind of prop you want on it. I would stay with lightweight, modern carbon fiber propellers.
Okay, sounds good. Trying to think of the next question here.
Well, I think one thing that is very important is in today's world, like you were saying, the whole thing about I don't think I could get an engine tomorrow by Lycoming, and I think and I was saying earlier about this thing about how every year we seem to be selling more and more engines and more people are accepting our engine, and that doesn't just come from the mechanical parts of the engine. It comes from Alyssa with the customer service that she offers to customers. And can she talk about that?
Definitely, I'd like to. And I want Dave to talk about the support that you might have outside the company with other people that have adopted this engine into their airframe. If there's kind of a block side or how you do that. I don't know if there is one or not, but let's let Alyssa tell us about the company side.
Yeah, I guess, Jan works a lot in the shop. I do as well. We both wear many hats. However, I get to do a lot of the one-on-one with the customers from the beginning of their questions all the way up until the sale, and a lot of times until that installation starts coming in is the first time really Jan sometimes gets introduced to some of our customers. So I think a big part of that is really being available to your customers. That's a really important thing. We really do pick up the phone, answer the emails. You're going to get responses right away, so you're not delaying your build. We're available on the weekends when people are actually working on their builds, so they're not, that 2-year project can become a little less because they can kind of keep moving forward. Outside of that, I just try my very best to treat people the way I would want to be treated, as cliche as that sounds, to the best of our ability. I think, and there's quite a few customers here in the stands too, and Dave has dealt with me more often than not. So he can obviously speak to the customer service, and I always like to be able to give people, I tell you, I can give you 50 names right now. Please talk with every single one of them. To ask them the hard questions, and they do, and that, I think that's really important to hear from customers and not just ourselves. You can kind of get what seems like debated material that we repeat over and over again, but when you really speak to other customers out there that are happy, that's what really sells your product and takes care of them.
Well, you talked about the install process and support for that, but as reliable as anything is, you're always going to have some little problems in the field. So I'm on a trip, and I'm just kind of like Dave did. He's out there for 10 days. He's over a weekend. He breaks down, and of course the local mechanic's not going to know how to work on this thing. Hopefully the home builder knows a lot about it.
Well,
So what you're saying, it sounds like to me that I can get that support even on the weekends. I need to do something to get myself going again. I'm aircraft on ground.
yeah, I guess a prime example of that is there's been many circumstances where maybe somebody has a prop strike or something of that nature. They're out in the back country and they're like, how do I get home? Or something's going on. That same day they can give us a call and I can have a gearbox in the mail next day and they can be back up in the air. With standard stuff and ready to go. That the gearbox and the dampening system that is on this engine actually means if you have that prop strike, you're not having to actually really touch the engine. That dampener kind of takes the loads of a prop strike, and it kind of saves you a lot of heartache and a few dollar bills at the same time.
I'm glad you brought that up. I hadn't really thought of that, but that's unfortunately not an uncommon problem. Like the guy in my hangar had a prop strike, and his engine's out for who knows how long now. So you're saying all we got to do then is remove the gearbox and replace it, and
Precisely, yep. And a lot of times you're not even necessarily replacing it. We can get one to you if you need it right away, but you can just unbolt it, send it to us. 24 hours later, I'll have it back in the mail. And typically there's absolutely nothing wrong with the gearbox. Maybe you changed a bearing or two, but you replace that torsion dampener that took the loads, that's $200. You replace your centering bushing, which is $25, and you bolt the gearbox back on.
wow. Can you tell us maybe a little bit more about the design of the gearbox? Because that's a unique feature. You don't really have any design in the engine, because I wanted to say Boeing. Honda did that for you. Tell us about, because that's a unique, you designed the gearbox, right?
Yes, I did. And
So tell us how that worked.
I'm going to talk about the gearbox. Let's say one tiny little thing first about, like you were saying, if you are out, you're a home builder and you're out in the field, and how do you get help? And that's an illusion that many people have, that in order to get help, I have to have a light combing or a Rotax or something that everybody supposedly can work on. Now, the reality of that is that the thing about the light combing and every FTO has every part in stock and all that, that's long gone. And there isn't an aircraft mechanic on duty on the weekend everywhere. Okay, you're more likely to land at an airport where there's nobody around. So who can then? And we've seen even in Florida, where we have the biggest Rotax dealer in the world, people folding up their airplanes and trucking it to where they are because there's nobody at that particular airport that can open that particular mission. Now, our engine is a car engine. Okay, any auto mechanic anywhere, or anyone that's worked on any engine at all, can work on that engine, including the builder, him or herself, because it is a sophisticated engine, but it's also very simple. It has 4 coils, has a few sensors. It's a pretty simple deal. So to change the starter, I'm not saying you should necessarily get a Chinese-made starter from AutoZone, but you can to get home. Then you can replace it with a genuine Honda one later. So you can get parts in every town, in every city, in every place in this country for that engine. So
That's a great point. So it makes me think, you talked about changing the computer a little bit with your own code. Can an auto mechanic plug in and do all the code reading? Does it record everything like it does in a car?
It's a little different than that, but yes, we do have a recorder that you can plug into a connector, and it will record your flight.
So a car mechanic, could he read it? Get a fault analysis of any sort?
It does have OBD2 capability. We haven't really used that very much because we haven't had any issues where it's something to do with the wiring or the engine or something like that. But if that ever came up, yes, you could use OBD2 and read a code like you're saying. Yes.
Cool. At least my oxygen sensor is not going to go out when I get a batch of bad gas.
Yeah, and it doesn't have an oxygen sensor.
Yeah, that's why I'm saying that. It's always a problem when that silly little orange light comes on in my instrument panel.
Yeah, about the gearbox, the thing about gearbox is, I've been doing this for 30 years, and when I first started, of course, there was no way you could start a company like that ordering 5,000 pieces of forged steel that's been ground into shapes that will make a gearbox. So So you do the best you can. You start out with a belt drive and you try that for a while, and then you figure out, well, you know, that's kind of good, but it seems like very easy. You got a belt drive and you can see it and how can go wrong and all that, until you realize that, you know, that belt drive is bolted to a hot engine, and you're side loading the crankshaft, and you've got greased bearings with no oil, so they're going to be like throwing grease everywhere, and the whole thing becomes like a toy. You can't really like jump in and go across the country like Dave did. So eventually you're going to need a gearbox. So then as the years go by, you know, you still can't afford all that stuff, so you take a transfer case, or you find something in the automotive industry where you can get the gears and modify them and make some kind of a gearbox. And then eventually you realize that, or you just take a chance with everything you own, and you spend, you know, $200,000-$300,000 on 10,000 pieces of purposely made gears. They're forged, they're ground, they have the proper spline where they need a spline. You don't have to cut anything off. They have the proper size bearings that can go onto this gear, and it becomes a custom gearbox for your engine. It's designed for that. It has the right ratio. Everything is perfect, and that's where we're at. You know, we order gears that are forged by 8,000 series steel. We get 10,000 pieces at a time, prop hubs, gears, drive couplings, and now you have something that's real, and that's where we're at right now.
Cool, that's a great story. The middle version you said was just an automotive transfer case?
Started with a Suzuki transfer case, and then eventually ended up with some a different transfer case from a Nissan. The first one was basically just use the whole transfer case, lock it into the proper gear you wanted, and put a front plate and a prop up. And then that involved into just using the gear from a larger car and machining your own housing. And then eventually into this, where everything inside that gearbox is custom made for that.
Reminds me of Johnny Cash with his 50, 51, 52 car with an adapter kit. So we've gone to no need for the adapter kit. We got the full housing for us. Technically, so Alyssa was mentioning how mechanically it works. You said the bottom there coming off the crankshaft is a
Yeah, what she's saying is, and what everybody that's researched is, and their biggest worry is, well, can you bolt a gearbox to an inline 4-cylinder engine and not have the cylinders? You know, obviously a turbine engine's very smooth, but a combustion engine makes its power through pulses. There's one cylinder firing at any one time. So this bang, 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 bang is not going to ruin the gearbox. And so you have to develop the proper torsion dampening system. And what we use is kind of a rubber coupling with like Kevlar rope and stuff in it. It's a commercially available product that we've modified and are able to use between the flywheel and the gearbox, and it's right out in the open. You can inspect it very easily. You can always, you know, it's never been an issue. It's been a very, very reliable system. Now you look at that gearbox, and some people will say, "Well, it's on stilts. How can that be reliable?" and all that. But obviously, if you have more than 3 standoffs, it's extremely rigid. And the design doesn't rely on the standoffs for it to be centered on the engine. It's kind of like we use a throwaway Delrin sleeve that gets placed on the bottom gear and then goes into the crankshaft, and that's what centers it within half a thousandths. So it's a disposable part. If you ever take the gearbox off, you put a new centering bushing, we call it. So that's a different way of aligning something rather than using dowel pins and things like that. And then makes everything more universal. The same gearbox with a just slightly different back housing can go on different engines and so forth and so on.
What we're used to the term TBO, which we know, experimental world. It's a recommendation only. What are you recommending on this? And is it a different time period for the reduction gearbox versus the engine?
Yeah, the gearbox is just like on demand. You know, you have a sight glass, you change the oil, you can read the temperature of the gearbox as you're flying, if one day comes along where you're reading a little bit higher temperatures than you used to, and you drain it and there's a little bit of metal on the drain plug, on the magnetic drain plug, then maybe it's time for the overhaul of the gearbox.
So you don't have a time period on that?
That's going to be a long time. I mean, let's just say 1,000 hours, but it's probably going to be 2,000. So,
Okay.
Yeah.
And then the engine, I know our engines now last forever.
I just reluctant to say that I believe it's going to go 4,000 hours because but I think it will.
Okay.
Yeah.
I mean, it wouldn't surprise me if it did.
Well, what we've got now is like we have people at 1,600 hours. Then we got Dave doing 700 hours in 3 years, and he's flying to every state in the country. And since he started flying the engine, like I was trying to prove earlier, that those platinum/iridium plugs will last for 1,000 hours. Okay, so everything has changed. The thing about the engine that people might not realize, because not everybody reads about engines every day. We got other things to do, and in fact, when you buy a new car, trying to figure out what's going on with the engine is like on page 54. They don't even show you the engine. The salesperson is going to show you the engine. And everybody cares about cup holders and neon lighting underneath the dash and all this other stuff. But what is going on in the engine, if you guys want to know, is that there's all kinds of stuff that has happened in the last 10, 15 years. One thing is they refer to it as friction reduction technology. And that's obviously has to do with EPA and environmental and making the engine smoother and better and less maintenance. And it goes all the way from like the 020 oil that makes the engine operate with less friction to coatings of the pistons, special piston rings, very short piston skirts, groove bearings that carry the oil much better throughout the engine, offset crankshaft to cylinders to make the engine turn easier because it's only making power on one side. So there's lots of things, and then obviously these engines have variable valve timing and variable valve lift and all that, and somebody will say, we don't need that in aviation because it's always at the same RPM and all that, and that's baloney. It is not. We don't fly exactly underneath the same circumstances all the time. And if you add a variable pitch prop, that's even further from the truth. The engine, like the way we operate our propeller, if we have a variable, is we have maximum throttle all the time. So what does that mean? That doesn't mean maximum power. It just means that there's no metal piece that restricts the air from going into the airplane engine. So then you can use the propeller to govern the amount of power that you're taking out of the engine, and because you're not closing the butterfly valve, you're getting this 5 to 6% gain in efficiency from lack of pumping losses, they call it, in the engine. So between friction reduction, no pumping losses, using the propeller to change RPM and loading on the engine, and the engine taking care of where the valves are going to be, where the timing is going to be, all that kind of stuff. You do need an engine that is infinitely variable to maximize efficiency, even in an airplane.
Interesting. I'm thinking, so we talked a lot about the gearbox. The turbocharger is only on one of them. And by the way, I guess the gearboxes they're not the same though, right? Each engine type has a different gearbox.
They're very similar.
But they're similar.
They're similar. They have different bearings to handle different loads.
Okay. I'm going to talk about the turbocharger then, which is only on the 195 horsepower. Obviously, in airplanes, we're using turbochargers for different reasons than cars. We want to be able to maintain power at altitudes that a car would never reach. So how do you operate that turbocharger? Is it normalized, extra boot? What are we doing?
Well, let me cover that, like the whole thing, and I'm going to try to be brief, but there's a lot to it. Like the turbochargers you see, like when you fly your Piper Aztec, and you look out the window at night, and you see this glowing thing in the nacelle next to you. Okay, so that's a turbocharger that's bolted to an air-cooled engine, which has huge drawbacks. If you turbocharge an air-cooled engine, the only thing that can cool the turbocharger is oil. Okay, and then you don't have an engine that's set up to have a turbocharger being bolted directly to the engine. So you have to use a lot of exhaust pipes that are slip fit that have to all come together to one location in order to use that exhaust gas to power the turbocharger. So in this installation, all that goes away. You take an inline 4-cylinder engine, the turbocharger can go, you cast the exhaust manifold into the cylinder head, then you use coolant to cool that. So, and then you take the turbocharger and you bolt it right to the cylinder head, which is a very small oval port in the middle, rather than having the turbo hanging off the side of the engine on cast iron or welded up tubing, which has to expand and contract and will eventually crack. So between cooling the exhaust gases in the intake manifold several hundred degrees before it hits the turbocharger, and then cooling the turbocharger with liquid and oil, you have a very refined and modern turbocharger system that you now can control with an actuator that is controlled by the computer that runs the engine. Because the turbocharger runs cooler, your intercooler can be smaller, because even though you can run up to 20 pounds of boost, which is like a ridiculous 70 inches of manifold pressure, the charge from the outlet of the turbocharger is cooler, which means smaller intercooler, which means less drag to the airplane, and on and on and on. So just because turbochargers are hated in the aviation industry right now, as in I would never buy a 210 with a turbocharger ever again because my maintenance went, skyrocketed. That's not true with modern installations of liquid cooled turbos.
That's really interesting. I love that. Now, are you normalizing it? In other words, keeping sea level pressure, and what's my critical altitude?
You could never make 195 horsepower out of a 1.5 liter engine unless you boosted it all the time.
Okay,
so
and that's what the car people want to do.
Yeah, that engine runs under boost pretty much all the time. You can have maximum torque at 1500 engine RPM. So it's always under boost. And yeah, so it's not normalized, basically, but you can go to 20,000 feet and the engine, it all depends on how big of an intercooler you put on it, as far as going up into altitude like you're asking.
Oh, okay, great. Let's pass the mic to Dave. So we talked about reliability and service on the road. You've got a lot of time on this thing. Sounds like you may be one of the high-time guys. You said you're kind of a beta tester?
Yeah,
What issues have you had?
I've had really zero. I consider myself the unofficial test pilot to destroy this thing. So within that, when they have a first flight, for instance, somebody's going to take their plane for a first flight, they'll say, "Hey Dave, are you available?" And if I am, I'll go fly out there, and we'll go over the other person's plane and inspect everything else. And at one occasion, that's what I did. I was flying out there to go give two people some demo rides. They were building a similar project, actually identical. So I landed after a rainstorm on a very slick, caliche-packed runway. And as I was taxiing in, I hit the perfect pothole and broke all my propellers. So I was like, oh man. Well, fortunately, it's very interchangeable. Jan was there, he inspected the gearbox. Bill was there, he had a new prop system. Everything was good, we put it back on, I flew out that weekend. So it's very interchangeable in that sense. So with that, the reliability of me flying reliability of me flying is that I have the confidence to fly literally anywhere in this country, knowing that I can have any part 24 hours shipped to me, and I don't have to take my wings off and bring the vehicle back. Or, because as we're growing, we're developing a very family-friendly network, which we do fly to other people's places now for the weekend, sometimes very impromptu. All of a sudden, several planes show up. But having that sort of friendship, knowing that if somebody flies to my airport, for instance, and something happens to their plane, I'll take a part off my plane, get them back home, and they'll just ship it back and we'll be all done. So we have a lot of friends, a lot of family in this, but the reliability of it is unless you hit that perfect pothole, you can pretty much fly anywhere you want.
Okay, how about integration with all the glass cockpit stuff we got? I mean, it talks to Dynon, Garmin, they know how to read everything. You mentioned something about gearbox temperature, which that's just another widget. What else is a pilot monitoring on this particular engine that's different than what you would consider a traditional aircraft engine?
I think first off, we integrate with everything. Everything on the engine is just sensors. So Dynon, Garmin, NGL, any avionics company, it's as simple as the 1/8 inch NPT you're putting in and just plugging right into the engine,
Okay.
and then it's going to read all the engine information.
So what am I reading as a pilot? You know, everybody's used to CHT and EGT and blah, blah, blah.
Yeah,
what do you guys read?
That's all out the door now. So you're not even monitoring any of that stuff. So you'll be monitoring your gearbox temperature, your coolant temperature, your oil pressure, and your fuel pressure, along with your voltage and stuff of that nature. When it comes to the turbo engine, you obviously have intercooler inlet and outlet temperatures and manifold pressure and stuff like that, because it's you have more things to monitor. But outside of that, that's really it. And you're running on your RPMs, and then you're good to go.
Which RPM am I reading, engine or prop RPM?
You're reading engine RPM.
Okay. So I got to come up with a number. Well, you guys give them the limits, I guess, in your
Well,
book.
yes and no. Whereas in like a Rotax, they run at 5,600, 5,800, and they don't want you to go below a certain amount. It's not good for the engine. You can't run really low RPMs. And I can pass this along to Dave as well, but I think he's been anywhere from 3,000 RPM to 5,000 RPM, depending on what he's trying to do, whether he's climbing out. You have those capabilities across that span.
He's trying to show off at the stoplight.
Yeah.
So I know road taxes, since you brought them up, it's kind of a long time to get that oil warmed up. So from start to takeoff is,
By the time, yeah.
what are we doing there?
I got a little thing on that, and that's remember I was saying about the integral exhaust manifold for the to cool the turbocharger. Well, that also directly hooks up to your heater lines. So within 20 seconds of the engine starting, because the exhaust is instantly hot. There's no such thing as waiting for exhaust to get hot, because it's firing the engine, right? Well, that exhaust is now heating that jacket around the exhaust, and that means that you can have instant heat from the coolant because you're tapping off right there to do the coolant. But that was an indirect thing that you said about how long. Okay. So you can go and fly. You can go and fly as soon as your coolant is like 100 degrees or something like that. There's no real limitation to that, and that comes back to the engine doesn't change a lot, and it doesn't grow or contract as much as traditional engines, because it's a very, very small amount of temperature change from running at idle and running at full power.
Well, that's the benefit of a liquid-cooled engine over the air-cooled. I mean, that's a compromise for air-cooled.
Right, and that's what Alyssa was saying. Like, there's only like 3 sensors on the engine. You don't have to monitor. Like, running an air-cooled engine is kind of like running, if it's a 4-cylinder, it's like running 4 separate engines. That's why every cylinder is being monitored separately. And because you have a liquid-cooled engine with the same jacket and the same coolant to cool in all cylinders, that all goes out the window.
Yeah, that's great. Tell you what, I bet we've got a bunch of questions out here.
Yeah, that sounds good.
We've kind of gone to the end of our time, but I don't mind staying here. We've used up a lot because you've got so much great information, but we have time to take on a few questions.
Yeah, absolutely.
Do you have any other information we could give that might help the questioners? Dave?
You were mentioning RPMs, what we fly at. And I do extensive testing. I have Excel spreadsheets. I've tested this thing every way I can think of. And what I find is I'll take off. I'm at sea level over there in Houston. So I take off at 5,800 RPMs, and I have tested it all the way up to 12,000 full power the whole way. So I know it'll do that. Normally I'll level off either pattern altitude or whatever altitude. And my most efficient cruise RPM is 4552 precisely. I can go faster, but it's just diminishing returns on the fuel economy. So a lot of my flying is sightseeing mode, or in this case, coffee mode. And I've had it down as low as 2.7 gallons an hour, flaperons down, and I'm just sightseeing, burning next to nothing, close to, was it 2.8 gallons an hour, something like that. So I can stay up a very long time.
I'm glad you brought up the fuel burn thing, because I think that'll definitely help. I'm sure that's a question we're going to have out here. Can you compare that to, am I going to burn less gas with this engine versus something else? In other words, that would depend on, the results would be because it's more efficient.
Yeah, and the direct injection definitely helps on that because of the way the fuel is sprayed onto the cylinders.
Yeah.
So that's a big benefit to everything that we do. Now, just like anything, it's all relative to what
Right, it
you're
takes
at.
so much gas to make so much horsepower.
So, I mean, a lot of the engines of the same horsepower are going to make burn about the same fuel, but we tend to come in quite a bit more efficient with that. And with the variable pitch prop like Dave has, you're even more efficient from there. So.
Excellent. So now I'm saving a little bit of money on the cost of the fuel and maybe burn a little bit less gas. Don't have to change the plugs. This is getting kind of nice sounding. So, yeah, Dave.
There's a reason I have 700 hours on this plane in less than 3 years. It's efficient to fly.
Yeah, and the fact that you got 700 means you didn't have any downtime.
Very little.
Yeah. Can we go to questions now?
Yeah, let's
Okay.
do it.
Holler it out a little bit. If I can't hear you real good, I'll walk up and give you a microphone, but we'll try it from here. Oh, sure. The props. Good question. So he wanted to know if I go with a constant speed prop, have I got a weight or cost penalty that you see on a typical Lycoming?
When it comes to a lot of people, an Airmaster or something like that is something that's commonly compared. Obviously, it has a bit more complexity and stuff in the spinner, as discussed earlier. So you have a bit more maintenance. Whereas I think Dave has like 500 or 600 hours behind this particular propeller with you're not really maintaining much to start. And I think all up, you're around 15 to 17 pounds with the Duke propeller that we offer. Part of that being because it's also a carbon hub, everything's really lightweight. The way we run it makes it super lightweight because we don't have all those extra components. And the Airmaster comes in increasingly, it's a lot more. It's around 30 pounds by the time you have an Airmaster prop up there. So
How
there's
about the cost part of it?
The cost is, it is more costly initially to buy a variable pitch prop that in 2 years, you're gonna make it back in fuel.
Yeah.
And yes, there's a lot of other advantages. You can add in pitch, it gets quieter, the propeller is more efficient. We talk about the engine, but the engine gets more efficient the more pitch you put in the propeller, because the propeller gets more efficient as a unit. The whole thing becomes more efficient. But as far as comparing it to a metal, a Hartzell propeller, all that, there's no comparison. I mean, these are experimental propellers that are the latest and greatest in technology. They're, like Alyssa was saying, carbon fiber forged hub, carbon fiber blades, super lightweight. It weighs nothing. And it's more affordable than other propellers of similar design out there, experimental ones. And most of that comes from, if you try to do an electric propeller, for instance, and you have to put a motor and a gearbox in the spinner to drive it from the front back, all those components are very expensive because they have to be very light and very, very strong. And also there are little issues that have to be ironed out, and they're always troublesome no matter what, where that little motor in the spinner is spinning, so the little brushes tend to have more power or tighter springs on it, which wears things faster, and it just snowballs. And then you have the brushes to transfer power to the propeller. And that's all gone with our design, because we have just a steel rod through the gearbox. and we have just a regular inline actuator next to the engine that's completely easily maintained or replaced or whatever. So there's very little mechanism in the propeller itself.
Okay. Up front here, there, blue. Exhaust what? What about the exhaust muffler? I'm going to have to get a little closer because of the helicopter noise. So the question was, oh, just talk about it. Yeah, he wants to know, okay, the exhaust system and the muffler system.
Okay, so there's several things about that. The one thing that I've discovered from working on an inline 4-cylinder engine is that it is an inline engine. Now, the beauty of that is there are no exhaust pipes running everywhere in the engine compartment. You don't have to tie 4 or 6 cylinders together with a whole bunch of piping underneath the engine. So that enables you that reduces your maintenance. You don't have slip joints that can leak, and you can breathe exhaust in the cabin. So that's one thing. The other thing is that, again, the integral exhaust manifold, what we keep bringing up, allows you then to have either a turbocharger or a very simple muffler in one location. And that's what we do on the non-turbos. It's on the other side. You guys are viewing it. It's a muffler that is very simple. It's very compact. It doesn't produce a lot of heat in the engine compartment because it's in one location. And it's you combine that with the able to now if you take that, it's quieter than a traditional airplane. But if you now take that and you put a turbocharger on, it is ridiculously quiet. I mean, they think we're an electric airplane. That's not so much true if you have a fixed pitch propeller and you have a regular muffler. Then it's just a little bit quieter than a traditional airplane. Now, if you have a combination of turbocharger and variable pitch prop, where you can run a lot of boost and very low RPM, it gets crazy quiet. If you have the turbocharger, if you have normally aspirated, but you have a variable pitch, then you can take advantage of reducing propeller noise by adding pitch to the blades, which quiets down the propeller, slows down the engine, reduces noise from the muffler. So yeah, it's a complex thing of a variety of things that end up being the final noise coming from the engine. But in general, our engines are incredibly quiet.
Do they all have mufflers?
They all have mufflers.
Okay, interesting. Blue shirt?
Does the engine provide the heat for inside the cabin?
Where do I get cabin heat? Is the question.
Right, and that's we touched on that earlier, that integral exhaust manifold, and you would use that. You would put a heater core in your cabin. We don't like to run rubber hoses into the airplane, so we, just like in most cars, the heater core has the aluminum or copper tubes coming out of it, and you would make grommets and stick them through the firewall and then hook up your hoses outside, and then inside, and that's where you would run your hot coolant, and then inside the cabin you would have a heat exchanger that would be around those tubes, and a fan and a switch. It's just like a car. And we have heaters available.
Can I put an air conditioner on it?
Yeah.
We live in Texas.
What I've learned about that is that it's a lot cheaper and lighter to work on ventilation and make lots of vents in the airplane, so that when you because the air conditioning thing is heavy. Yes, you can put a compressor on, but it's heavy. It puts loads on the serpentine belt. They can take out other components on the engine if you break the belt. There's a lot of reasons why you should not do it. And what I've found is that because you have a liquid-cooled engine and you don't have to worry about it getting too hot sitting on the ground, as soon as you put your butt in the seat, you start the engine. The first thing you do. So either you leave the doors open or you work on ventilation rather than installing air conditioning.
Yeah, there you go. I was just thinking about stuff I got in my car, so cool. Questions? More questions.
Yeah, top of the row here.
Purple. Sorry, I was listening to the wrong.
That's okay, I got it. He asked where do we get the engine cores.
Oh.
I can elaborate on that. It's a little more in depth, but it's actually quite simple. Honda does not sell engine cores to anybody. They will not do it. They'll sell you all the pieces and parts if you want to put it together yourself, and it'll cost you $30,000-$40,000. So how we do that is just like Dave's engine here. He had like 6 or 7 miles on it. 8 miles. That's what he had on his engine when he received it. The gentleman over in our booth had 10. So we do that by insurance claims. A lot of times you'll have like vehicles that are on a train that gets derailed and they don't actually touch the engines, but they have to be sold in insurance. It's an insurance claim. So we wind up taking those engines and pulling them or getting them out of the car, which means we have a brand new engine that is built by Honda. It's a 2021. We don't use old cores and stuff like that. We're not remanufacturing anything. We're not opening it up and tearing it down, and that's how we get it. And because there's so many vehicles on the road, we really do have an endless supply of anything and everything that we need, and that keeps your parts exactly as they need.
So does the manufacturer change the engine much? You know, body styles change regularly. We still dealing with the same engine we had 5 years ago, or what?
Yeah, this one's been around for about 8 years, and our turbo engine's been around for about 6, and will be around for many, many more. Obviously, like anything, they do change their engines, and when they do, we kind of move forward in doing that. Many years ago, we had what was called a Viking 110, and we still have about 400 of those out flying around. But that was this engine before it was direct injected and on its side. And we still, because a lot of our parts are used across all of our engines, so all those parts are available, just like you can still go get your old Chevy piece that you need at any auto parts store. All the other parts we still have. So none of that really changes. Even though maybe we change or introduce more models, your part availability, your maintenance, and everything all remains the same.
Okay. So you follow hailstorm pretty.
A little bit.
Near that engine.
Yeah, so it really enables us, like I said, because there's so many cars out there, there's an endless supply of anything and everything we want underneath the specifications that we would like.
That's neat. That's really neat. I'm glad you asked that question. On the top of the bench here. Ethanol?
No, not really. You can use, most of the time, most people are just using premium pump gas, non-ethanol, or it's not ethanol free. So it doesn't matter. It doesn't have to be one or the other. I know the road taxis, for example, they want it to be ethanol free. It doesn't really matter if your airplane's going to sit for 6 or 7 months or something. Obviously drain it, put 100 low lead in it to stabilize it, or drain it completely.
Yeah, that's one issue that airplanes probably don't get flown as much as your car gets driven. But I mean, the engine was designed to burn the ethanol fuel. It's just a matter of it sitting around, coming up, and all those other issues with ethanol.
Yeah, so just premium pump gas is really what it's still an airplane engine. Don't go try to find the cheapest gas around that's been sitting around at a gas station with the degradation of low-grade fuels.
Well, if Dave can talk to that, doing 48 states in 10 days, how was access to car gas?
Finding car gas at airports to me was extremely difficult. I only located 3 places in the entire country that on my route had auto fuel. The rest was courtesy car and donations.
So that means he took a siphon with him, and if you've ever gone to an airport and the courtesy car was out of gas, you know David been there.
Yeah.
Maybe, I don't know, can you carry a plastic jug with you?
I carry
a courtesy car. And
Well, I don't know if you can see through the door there, but on the passenger seat is a 5-gallon jerry can, which I named Wilson. So he flies along with me.
You and Tom, yeah.
Yeah. So I just get a courtesy car, and on this trip it was usually no more than 2 trips.
Sure.
I had 10 gallons, and that got us to the next destination to get fuel.
Cool.
One little thing about that, though.
John's got something here about the gas.
Yeah, since we're talking gasoline, don't let the thing that, you have to run to a gas station to get gas to scare you away from using a modern engine, because that's all changing. It used to be, we said 10 years ago that, 100 low lead's going to disappear, and it still hasn't. But the fact is that right now that is changing. The lead will disappear. Several fuels are being approved by the FAA right now, and they're non-leaded substitutions for 100 low lead. So that's all.
Also have to be on this route.
Yeah, and like Alyssa said, we actually contacted like Swift Fuel after the fact to see if they would, or we left them a message and they never got our message, but they would have also been maybe able to like help us and sponsor us, because Swift Fuel already has gasoline around the country, and this is coming more and more and more every day that you're going to find non-leaded fuel on your route. And if you can't, you use the additive, so it's just going to get better as far as the availability. In fact, buying something that might need 100 low lead might be the scary thing right now. Listen.
I wanted to elaborate slightly on that. Obviously, he had very specific points that he needed to go to make this trip done as quickly as possible and do that. But we travel every year from Florida to Mexico, Missouri. If you plan your route, you can find the MoGas at plenty of airports and stuff like that. So that's kind of a non-issue. And like you said, if you don't, you put the 100 low lead in and you use that Declan additive, which all of us experimental engines outside of the Continentals and Lycomings, we all have to use. Lead is not great for it, so you use that additive when you need to. Other than that, you use MoGas and you can save a few bucks and it's better on your engine.
Excellent. Oh, up top, blue shirt.
Higher horsepower, that's what you said, yes?
Yeah.
At this time, no. A lot of that comes down to, in the experimental market, there's not really a huge need for anything outside of what we already offer. And when you get up into those higher horsepowers, you're looking at a very large amount of redoing R&D that we've already done. It's very easy to go low in horsepower. High in horsepower, we start looking at a lot of R&D, and it'd be years and years and years before we even release it into the market and put those kind of testing hours on something that was needed.
Sounds good. Yeah, 200 horsepower, effectively 195. I mean, that's going to power everything except for four-seat airplanes out there.
Yeah.
The larger.
And we even have like the Zenith 801s, which are 4 seats, that they fly behind the 195 turbo, and it still performs incredibly due to the thrust that the actual engine creates.
That's more horsepower than any production aircraft would have.
And even new four-seat airplanes that are coming out, like the RV-15 and the Sling, they're based on smaller. Maybe the 15 might need like the 195, but the Sling, they carry 4 people with the 915 road packs, which our 150 will handle.
Yeah, that's quite an accomplishment, by the way. They had, if y'all didn't see it, Sling. They just brought 3 their new high wing aircraft all the way from Johannesburg up here to the air show.
That's a haul.
That is a haul. So that airplane was built or designed specifically for long range. And have you made any inroads with them for them to use your engine?
We always have people that approach us with certain things like that, but until somebody actually is ready to follow through, we absolutely can. It'll definitely fit the platform and it'll perform well.
Cool.
But until someone wants to do that, not at this time.
Well, I think we might need to wrap it up, and I don't any one really pressing question. If you do have it, their booth is, we're 20 feet away from them.
Yep.
Even a putt from me, maybe. So I just want to thank you guys for coming out. We stayed a little bit extra long, but I learned a lot myself. I hope you all did too. And it's the concept of automotive engines and airplanes has been around for a long time, but we've got a lot of them that were left in the dust for various reasons. But you guys have how many engines out there flying now? We
actually have 1,200 engines out in the field. I'd say about 75% of those are flying. The others are still building.
Okay.
Stuff. We have cozies and stuff.
So we're talking 1,000 engines. That's we're critical mass, I think.
Yeah. Oh yeah. I think when people have the idea that high RPMs and can't work in aircraft and they're never going to last, they were not meant to do that. I think after the past 13 or so years doing the Honda specifically, you wind up proving that that is in fact not the case. So
Yeah.
people stop questioning things like that and realizing that it can do exactly what we said it can do.
Great. Well, how about a round of applause for Jan and Listen? Dave, I think they gave us a lot of good information. I definitely want to learn more myself. So, what's your website that I can learn without
Yeah.
having to call you?
Yeah, you can obviously call or even text us anytime. We respond any old way. But www.vikingaircraftengines.com, and you can find all our information there, and even watch a bunch of installation videos if you want.
Do you have any other social media access?
Yeah, we do Viking Aircraft Engines on Facebook. We have groups with Viking engine owners and prospects. We have an Instagram. So all of that is heavily monitored. We're always there. And the group that we have, the Viking engine owners and prospects, is really wonderful because if we are not available that second, you have, like Dave tried to say, we're a family. That's you.
Good.
When you buy a Viking engine, you've been welcomed into the Viking family, and we're all here to help each other.
Maybe happy customers could post a TikTok dance
I
celebration
can
dance.
see it coming soon. Yeah.
Okay.
Thank you.
Well, thanks a lot, guys.